Right, we're going to look at how to multiply things that have indices in. So if we have something like 3 to the power of 5 multiplied by 3 squared, we could whack out a calculator and get the value, or we could use long multiplication, but we can actually do something useful and simple here. 3 to the 5 is a bunch of them multiplied together, and 3 squared is a bunch of them multiplied together. And we're also multiplying these. Now in that row, we've got 7 of them. So that's the same as 3 to the power of 7, which means we've simplified this expression into this expression. And the thing we want to spot is there a cunning rule that gets us from there to there? And hopefully by now you spotted it. There were 5 here and 2 there, and we got 7. So we can just add the indices. Now, this works whether it's numbers or letters. So if we have p to the power of 8 multiplied by p to the power of 4, that's p to the power of 12. 8 plus 4 is 12. Very simple, very straightforward. One thing to point out though, a to the power of 3 times b to the power of 4, these have different numbers in the base, which means when we count them up like this, they won't all be the same. So in fact, that doesn't simplify very much at all. There's nothing we can do to combine the a's and b's because they're different. If we've got a bunch of them floating around, maybe we have a to the 5 times c to the 6 times a to the negative 3 times c to the 5. We can do the same thing. Looking at the a's, there's 5 plus negative 3, which is 2. So that's the a's there. And then looking at the c's, we've got 6 and 5, which gets us c to the 11, because 6 and 5 is 11. So when you're multiplying things which have indices in, have powers in them, as long as they're in the same base, you can just add the powers together. You'll see this in textbooks, usually written this way. A to the m times a to the n is a to the m plus n. That is index law 1. And there are 2 others I'm going to show you, hopefully. Enjoy!